class will focus on preventing personal contact with basic measures to prevent accidental contact with energized bodies. Residual current protector, also commonly known as leakage protector. It's the same concept, and the safety voltage. If there is a leakage phenomenon, or a short circuit or a person is electrocuted, leakage protector is how to cut off the power. To protect people or equipment, students recall, we in the power system. The main purpose of safety is to protect. Which parties are safe? We've covered these in previous contents have also covered. Mainly to ensure personal safety, safeguard equipment safety. Safeguard the safety of the power grid. These three aspects. First, let's look at the concept of residual current. To understand the concept of residual current, we can figure out residual current protector action principle. Each phase including neutral of the low voltage distribution line. Under normal operating conditions, the sum of current vectors is zero. Three phases are symmetrical, balanced, but when electric shock occurs in the circuit, a short circuit or a leakage, the equilibrium is broken. Then the vector sum of the currents is not zero. The current generated, this current is called residual current, also known as zero sequence current in the system. Then residual current protection is the use of residual current action protection devices to prevent electrical accidents, a safety technology measure. This residual current protective device is called a residual current protector, also called leakage protector. There is an abbreviation RCD. Next, the function of the residual current protector. It has two main functions. First, in the electrical equipment or line, leakage or ground fault occurs, can cut off the power supply before a person touches it. Second, when the human body touches the charged body, can cut off the power supply within 0.1 seconds, thus reducing the current on the human body injury. We all know a concept. The longer the current acts on the human body, the greater the damage to the human body, and this very short time, the degree of damage to the human body is greatly reduced. Residual current protection device mainly consists of detection circuit, judgment or amplification circuit, and the implementation of the circuit is composed of three parts. First, look at the detection circuit. The detection circuit is made of zero-sequence current transformer. The detection circuit is composed of a zero-sequence current transformer, which converts the leakage current of the power grid or electrical equipment into a secondary signal circuit. As I just said, when electric shock occurs in the circuit, short circuit or leakage, the three-phase balance of the circuit is broken. The vector sum of the currents is not zero. This creates a residual current or zero-sequence current. The current in the secondary circuit of the zero-sequence current transformer. The current in the secondary circuit is no longer zero. A residual current on the primary side of the secondary current. This current is output to the lower amplification or comparison circuit. So we see that the residual current protector is the zero-sequence current transformer. It detects if there is a short circuit in the circuit, leakage. It's a key device for detecting electric shock in the circuit. The second is the amplification or comparison circuit. It is based on the signal sent by the detection circuit, processing or amplification, and compare it with the set value to decide whether or not to send it to the actuating circuit. If the signal is small, compare it with the factory fixed setting value. It doesn't reach the standard value for actuation. Then the circuit will continue to operate without being cut off. If the signal is larger than the factory value of the factory fixed setting, then the circuit is cut off. Finally, there is the actuator circuit. It is based on the signal sent by the judgment or amplifier circuit to send the signal. It will make a decision to cut off the power or continue to turn on the power. For example, in household air switch with leakage protection, it has an overcurrent detector. If the signal reaches the condition that the actuating circuit operates, the overcurrent detector disengages. The air switch trips, breaking the circuit. Residual current protective device. Where should it be installed? Its application range is still very wide. One belongs to category mobile, electrical equipment and handheld power tools. 2 production electrical equipment. 3 construction site electrical machinery and equipment. For electrical equipment installed outdoors. 5. Electrical equipment for temporary use of electricity, especially in outdoor temporary construction. No leakage protection equipment is installed, and the accidents that result are not uncommon. One of the cases we're going to talk about. Analysis will involve 6 organizations, schools, hotels, restaurant, enterprises, institutions and residential units, etc. In addition to wall-mounted air conditioning power outlets, other power outlets or socket circuits, 7 swimming pools, fountains, electrical equipment in bathtubs, 8 electricity supply circuits and equipment installed in water. Special mention is made here of fountains. Electrical equipment in baths, because of the humid environment. It is easy to lose insulation protection. Must be installed leakage protection equipment. There are too many lessons to be learned here. Later cases will also be mentioned. 9. Hospital electrical medical equipment that may come into direct contact with the human body. Electrical medical equipment, of course, in the production and life of the operation of residual current protective devices also need to be maintained. In this point to the students to explain, 1. Leakage protection equipment into operation. Should be an annual census of the protection system. Check the focus of the project are. Test leakage action current value is in line with the provisions. Measure the insulation resistance of the power grid and equipment. Measure the neutral point leakage current. Eliminate all kinds of leakage potentials in the power grid. Check the transformer and motor grounding device. Check the transformer and motor grounding devices for looseness and poor contact. The electrician should test the protection equipment at least once a month. Test the protective equipment at least once a month. Whenever a lightning strike or other reasons, the protective equipment. A test should be carried out. Here we come to the leakage protection air switch for our home. Generally, the air leakage protection switch for our home is rated current 638 of air leakage switch. Look at the picture. There is a small orange button. There's a reminder to press it once a month. This is the test switch. You press it once a month to test if the leakage switch is good. But in our day-to-day life, we do neglect this problem. Especially in a rented house, when we don't know much about the wiring of the circuitry. We always try our best to test leakage switch performance. It is also an attitude of responsible for the safety of your own electricity consumption. 3. After the protection equipment is activated, if no accident is found after checking, you are allowed to test the power supply once. If it operates again, the cause should be found. Find the fault. Do not force the power supply continuously, for it is strictly forbidden to remove the protective equipment or force the power supply without authorization. This point also needs to be emphasized. Some people, because of the leakage protection, often trip, and it is too much trouble to remove the leakage protection. Do not realize that the leakage insurance frequently tripped is because the circuit has problems. There are faults. Hidden danger should be eliminated as soon as possible. Removing the leakage insurance is tantamount to condoning the existence of faults. For the accident hidden buried, 5. Leakage protection equipment failure should be replaced in a timely manner and repaired by professionals. 6. In the scope of protection, occurrence of personal electric shock casualties should check the action of the protective equipment. Analyze the reasons for failure to protect. Before the investigation should protect the scene, do not change the protection equipment. The following from a construction, a civilian to cases, to illustrate the importance of using residual current protective devices. First, let's look at the first case. Construction case. We will look at the accident. On October 5, 2017, a city's Huanyu Engineering Co., a worker was carrying out welding operations. Touched a metal part that was connected to the power source of the welding machine, connecting the metal part of the leakage, resulting in electrocution. He was sent to the hospital and died. This kind of construction cases, we can use the 3 elements method to analyze the cause of the accident. To propose preventive measures, the cause of the accident. First of all, from the safety awareness. The worker of the engineering company was seriously lacking in safety awareness. He started the work without wearing gloves and other safety tools. Secondly, from the technical measures, the welding machine shell leaks electricity. The metal parts were mistakenly energized. because the welding machine exposed. Conductive parts are not connected to the protective wire. The whole line is not installed leakage protection device. What I just told you. Mobile equipment such as the welding machine in the case study. In the construction circuit, must be installed leakage protection device. In this case there was no installation at all. 3. From the organizational measures, safety management is missing. There was no person in charge of the work. There is no guardian of the work, leading to unsupervised violation of rules. Preventive measures. 1. From the ideological safety awareness. Must improve the safety awareness of employees. If the employees themselves are not protected, shall not work. 2. From the technical measures. After taking measures to check the electricity, confirm that the equipment is not charged. Insulated gloves. After insulated boots and other protective measures are in place. Lines. After installing the leakage protector according to the regulations. Construction work can only be carried out. 3. Organizational measures. Operation authorization procedures must be carefully carried out. 2. The construction units. Safety supervision of operation safety. Site safety risks can be controlled. Such accidents can also be avoided. The following analyzes a case of residential electricity. This case is not a construction or electrical operation. We can't copy the analysis method of the 3 elements, for example, organizational measures, such as work permit, work supervision system, etc. But ideological safety awareness, technical measures, there are many similarities. Let's take a look at this case, the accident. On the evening of August 8, 2019, Longgang Street, Longgang District, Shenzhen Longxi Community. A pregnant woman was electrocuted while bathing. Husband rescue operation is improper. Both were electrocuted and died. The incident was only discovered the next day. The accident is a leakage of electricity caused by electrocution. The cause of the accident, safety awareness. Lack of basic knowledge of electricity safety. Serious lack of awareness of safety against electric shock. Wet and watery environment cannot be blindly rescued, technically. Electric water heaters are not installed leakage protector. Rental housing facilities are simple. Deteriorated electrical wiring. Loss of insulation protection. The direct cause of the accident, preventive measures. Enhance the publicity of electricity safety. Residents should also have some general knowledge of safety. Discovered electrocution, first should cut off the power, only then can rescue. And electric water heaters must be installed leakage protector. Lastly, I'd like to talk about safe voltage. This is more familiar to students majoring in electricity. In some occasions where the risk of electric shock is high, use of mobile, handheld electrical equipment running lights, grills. In order to prevent personal electric shock accident, safe low voltage can be used as a power source. This voltage value, which does not jeopardize personal safety, is called safe voltage. We all know, the safe voltage is 36 volts. The purpose of using safe voltage is to limit the voltage that may be applied to a person, is limited to a certain range. The current flowing through the human body does not exceed the permissible range. So how is the safe voltage value 36 volts? How is it determined? There are 2 quantities involved. One is the permissible current value of the human body. The limit value of current tolerated by the human body, AC according to 30 milliamperes, to the human body resistance value of 1000 to 1500 ohms. Then the product of the two, 36 volts, is more reasonable. But in places where secondary injuries may occur, such as in swimming pools, bathing pool, electrocution may result in drowning. For such particularly dangerous places, AC can only be used at 5 milliamperes. What is the safe voltage for these places? It's about 5 volts. Okay, that's the end of this lesson. We'll see you in the next class.